logic. So we have 3 laws of logic that we have to be concerned with. All of them are used to justify the validity of a set of statements or just one statement. So you're basically saying if something is true or false based off of one of these 3 laws: the law of detachment, the law of syllogism, or the law of contrapositive. Those 3 laws are what we're going to be using to justify that something is true or false. If it doesn't fit into one of these laws, logically we're just going to say that it is a false statement, or it's invalid. Really, invalid and valid are the words that we're going to use. The reason we're using those is because it falls in line with logic, not necessarily that we're stating that it's a true statement. It's not like we don't want to use our background knowledge. We don't want to decide based on real world experience, we know this is true. We want to use just the logic that's given to us and decide whether it's valid or invalid. So the law of detachment is the simplest one. If P then Q, that's just a normal conditional statement. That's our first statement. Any conditional statement. Statement number 2 is saying that P is true. Basically saying, yes, this is true. Then we can conclude that Q is true. So if you know the hypothesis is true, the conclusion is also true. So statement 1, if a student gets an A on the final exam, the student will pass the course. That's our conditional statement. Rebecca got an A on the final exam. So it's saying this part of that is true for Rebecca. So the second part will also be true for Rebecca. Our conclusion is that Rebecca will pass the course. It's just following the logic of a conditional statement given that the hypothesis is true. The law of syllogism is really similar to the transitive property from algebra. We're also going to have the transitive property in geometry. But for some reason, we didn't want to call it the same thing when we're dealing with logic. But the transitive property in general is if A equals B, let me write it as an if-then statement. If A equals B, and B equals C, then A equals C. So we do not need the middle step. We don't need B at all because we know A is equal to B, B is equal to C, so we can just jump over that middle step and say that A is equal to C. This is the exact same logic. It's just not with an equation. It's just with logical statements. So we have a conditional statement, if P then Q. Another conditional statement that links the conclusion, Q, to a separate conclusion, R. Means we could just jump over the Q part. We don't really need that. If P, then R is our conclusion. So statement 1, if a whole number ends in 0, then it's divisible by 10. If a whole number is divisible by 10, then it's divisible by 5. We don't need this middle part. If a whole number ends in 0, then it's divisible by 5 is our conclusion. These 3 dots mean therefore. That's what we say at the beginning of the conclusion. We have a statement, therefore we can conclude something else. Last one, law of contrapositive, is basically saying that the contrapositive is true if the conditional is true. So if P, then Q, just our normal conditional statement. We're starting this one with not Q, and that tells us that not P is true. That is the contrapositive. That's why it's called law of contrapositive. Not Q leads us to not P. If you're a parent, then you have no children. Sorry, that's not true. I said that wrong. If you're a parent, then you have children. You have no children. So it's saying this part, Q, is not true. That leads us back to this part not being true. You are not a parent. You have no children, so you're not a parent. That's the conclusion. All right, Alright, let's do a couple examples where we're just trying to identify which law of logic we're following or decide if it's invalid. If you read a good book, then you enjoy yourself. If you enjoy yourself, then your time is well spent. Don't really need the enjoying yourself part. We know that a good book leads you to enjoying yourself. Enjoying yourself leads us to time well spent. So, if you read a good book, your time is well spent. That is the law of syllogism. It's basically the transitive property. If an angle is obtuse, then it's not acute. An angle is not obtuse. So let's label this as P and Q. An angle is not obtuse. It's saying this is not true, so it's saying not P. If it had said not Q, then it could be the contrapositive, law of contrapositive. But this is saying not P. We don't have a law that starts with saying that this is not true. Really, that's called the inverse error. That's assuming that not P will lead us to not Q. But that is not the case here. This one is invalid. I'm not sure why I'm struggling to write right now. If you recognize that something is either the inverse or the converse, that is an error in logic. Those are not necessarily true. If there's lightning, then it's not safe to be out in the open. Maddie sees lightning at the soccer field. It is not safe to be out in the open. So it's saying if there is lightning, you can't be out in the open. Maddie sees the lightning. We're saying, yes, this is true. Then we can conclude it's not safe to be out in the open. That is the law of detachment. If an animal is a red wolf, then its scientific name is Canis rufus. An animal is not named Canis rufus, so let's label that as P and Q. It's a red wolf. We know its scientific name. This is saying it's not called that Canis rufus. This is saying not Q. Leads us to say that it's not a red wolf. That is not P. This is the law of contrapositive. We're saying the second part of that statement, the conclusion is not true, so we can conclude that the hypothesis is also not true. That is the law of contrapositive. One thing I want to show on the you try. So for the first three questions, you're using these two as your original statements and you're trying to draw a conclusion. On this part, you're just saying if they're logically equivalent, if they're the same. Really, logically equivalent is a key giveaway for you're looking for the law of contrapositive. That means those two statements are the exact same thing, the contrapositive and the original conditional statement. They have to be the same. This middle section I think is a little bit confusing, so I just want to go over one of those examples. So we're writing that in symbolic form. It's really the way that we originally talked about these, that statement 1, statement 2, except I want to write that in symbolic form. So I'm just going to really rewrite this in symbolic form first. If it rains, then vegetables grow. If it rains, vegetables grow. Second statement is that it rains. So these are our two statements, and then based on that, we're going to use the law of detachment to conclude, therefore, V is true. So these are the two statements rewritten. This is the conclusion that we're making. You're writing each set of premises in symbolic form. That's this part. And then the conclusion of the argument is that part. Hope this helps, but like always, ask if you need it.